easy to grab. And this is the last one. Look, it is very important to know which features we should pick as our columns, because you have tons of possibilities, right? What are the features that we should find for our decision tree or classifiers in general? There's one good thing, that in deep learning, technically, the feature engineering, partially, a good part of it is done by the deep learning by itself. So you don't need actually. But the question is, if we have option to give all the responsibility to the computer to decide which features to use, or our intervention to say, okay, this one is needed, this one is not needed. Which one is better? Rely on computer?
Yes. Rely on computer.
If you know the relevance of some, you know.
Satish, one day you are going to replace me with one laptop. Well, technically, yes.
I'm just saying, if you know which ones are relevant, but assuming that you don't know anything, I mean, let the computer.
Yeah, in the real world, like it's hard to analyze the data. Right, that's the hardest part of the job. Like you have to analyze the data, and for example, traffic light automation.
Mm-hmm.
Like the input data is like endless. Like
right,
video camera, motion sensor,
right,
and
look,
everything.
I'm not talking about that part. That
for example, I said like so. Yeah. Ideal scenario is like the machine should do everything.
Mm-hmm. Well, let me just simplify the case. Imagine that we are talking about reading the handles of a clock to say what time it is, right? So simply, if we want to get the features, analyze it by neural nets, it takes hours and hours to analyze it and then come up with final answers. But imagine that if we simplify, we get rid of the outer side, which are the numbers, and we get rid of those kind of dots, and we just simply calculate the angle of the long handle and the angle of the short handle. It is going to be as simple as single classification. I mean, just lookup table. Even you don't need to bother using any machine learning, let alone deep learning. Long story short, if you can use appropriate features, you're gonna reduce, sometimes eliminate the whole process of the computer. Right? So it is very important to find features. But the good thing is, computers, they work similar to us, so that is why that I quickly just tell you. The guy that I borrowed many of the content from him is Josh Gordon. He said classifiers are only as good as the features you provide. The thing is, binary classifier, we worked with this, right? We talked about this, apple and orange. But look at this one. Greyhound versus Labradors. Imagine that we want to just see, for this toy example, we want to see which one, based on the features. We fit features and we expect to get the classification to see which one is Greyhound, which one is Labrador, right? Look at this one. We try to work with two of these guys. One of them is height in inches and eye colors. Guys, honestly, I had all those slides from Josh Gordon, but providing these set of slides, I mean, I generated 5. It took me almost 1.5 months, close to 2 months. I had the whole content. It's a kind of very time-consuming process. I'm telling you. One of the problems is the version changed. Some codes didn't work, and finding the solution was not a kind of easy job. So the height of inches and eye colors. One, we say greyhounds in general, they are something like 28 inches tall, But these guys, Labradors, which they have some subsidiaries, some other sets, they are 24 inches, in average 4 inches shorter. So and the thing is, the eye color, regardless of the breeding of the dog, the chance of finding brown eyes versus blue eyes is 50-50. So if you just, look at the eyes, it is brown, you cannot say, okay, it is Greyhound or if it is Labrador. You already know the idea that if that feature is useful or useless, because technically it tells us nothing, right? So let's see, well, technically we have two features, height and eye colors. The other thing is, let's just see, because we have different variety of dogs, right? This is my favorite, golden retriever. Anyway, we generate something like 28 plus 4 numpy dot random normalized of greyhounds. We say 500 of each. So we generate 500 of each types, right? And then we say, okay, let's just draw a graph for us, a histogram. And that's the graph that we receive. So you see, in the most left side, you can say by kind of high certainty that if it is something like 18 inches tall or 15 inches tall, it is for sure what? Greyhound. And if it is in this one, high probably it is Labrador, right? Lab was the brown one, right? Yeah, yeah, Labs. But the problem exists for the time that you want to say, okay, how about these columns in the middle? There isn't any certainty for that. So you want to bring another feature to give you a... Look at this. I implemented that in Jupyter Python as well, so you can use any environment that we learned. And I already talked about Greyhound and Labradors, so the short ones or the tall ones. Look at this one. Technically, if we use the eye color, it tells us nothing, right? Because you can't say, okay, in the middle, I'm gonna just add eye color and see, okay, if it is Greyhound or Labrador. The chance is 50-50. Just 1 minute, 30 seconds. Think about the other features that you want to add to the game and think about them as the possibility of the features that can help us too. What could be the features? Color. It could be. What else? The hair length, maybe.
Speed.
Speed, yeah. Maybe some breedings are heavier, some breedings are. So exactly the way that you think of the problem, you can just, think computer needs such things, right? So hair length, speed, weight, and so on and so forth. Right? And look at this one. We already said something that gives us nothing, we should get rid of it. So the column should be informative. Look at this one. The important thing is when for the most values, the distribution is something like 50-50, technically it is useless and throw it out. If you want to grab something out of these slides, this is the thing. It should be informative. The second thing is, should it be independent or not? Let me ask you one question. We only have technically one feature up to now, which is the height. So we have it in inches. How about converting that to centimeter? And then we have two columns. I want you to vote and say, is it going to help? Is it going to be neutral? Or is it going to be harmful for the... How many of you think that this is going to be helpful? Just me?
Converting everything, like all of
just the column, just you have one column in inches, just have another column in centimeters. Is it going to be helpful? Useless? How many say that it's useless? 1, 2, 3, majority. How many of you say that it is harmful?
Yeah.
Yeah, just one said yeah. But
I say, I'm not sure.
It's
Yeah.
irrelevant data. I would say it's harmful. So
okay.
Duplicate.
So 2.5, right? So let me just give you the answer. The thing is, guys, the algorithms are not that much wise enough to understand, okay, this is something different. So they give credit to something that they already gave credit before. So it's gonna receive double credit for something that it needs just one. So that is why that we can say it is harmful.
it's going to reinforce that trait. This is going to reinforce that.
Exactly.
Okay.
That is why that the answer is we need to just work on the independent data. They shouldn't be dependent. Maximum independency. So avoid redundant features or independent. And the last thing is, let me ask you this. This is kind of, question as well. That imagine that you know how many days you have to wait to receive an actual parcel or package from Ottawa. So you have the distance, which is 400 kilometers, imagine. And you want to estimate, based on that knowledge, what could be the number of days that you have to wait to receive a package from Vancouver? Do you think that how many ways we can do? We can use simply the distance, kilometer or whatever, and we can use latitude and longitude. So Alec, which one do you prefer? Using the longitude and latitudes and the difference between these two, or the simple ages? The distance.
Yeah, I would say the distance.
The distance. Seriously, distance. Okay, let's start from here.
I think if we just use either one, that they're both not enough.
I imagine that it is enough. We have to choose one.
Okay, now choose the other one.
The other one means altitude and longitude. Latitude and longitude. How about you?
No idea.
No, you choose nothing. I'm gonna wait till the package arrives. Why bother?
Latitude and longitude.
You don't know as well?
Latitude and longitude.
Latitude and longitude. Okay.
Yeah, the same. Latitude and longitude.
Okay.
Distance?
Distance. So we have two distance and lots of longitude.
Distance for sure.
Distance. Oh, for sure. Okay. Anything is acceptable.
Let's go distance for sure. There's some
Okay. Yeah. That's how you can just impact the vote.
Distance for
sure. Okay, you know the answer. So the thing is, guys, computers exactly like us. If I give you the longitude and latitude, it takes time for you to start processing.
Rasa, but with the latitude and longitude, we can easily find out the location name and then like calculate the from and to, like distance from it, like easily.
You said that. Okay. We need to do calculations.
But it will not be time consuming, right?
Okay.
And it
You're
will
talking
be
about
like
in general.
yeah, in general, like
So it's extra processing, is that
Yeah.
the point?
The whole idea is, guys, I'm not insisting, saying this is the absolute truth, but the whole idea is whatever is more time consuming for us is more time consuming for computer.
I mean, that will be with latitude and longitude we can compute different routes possible. Not the shortest distance. Like we can find out the different routes possible, and we have more
You
information.
want to say that it's going to increase the accuracy,
Yeah.
right? Kind of thing, because in just distance, maybe the route is like this, and we don't have. How about I tell you, okay, even if you have that, let's just assume the shortest path. I'm not gonna say that it's gonna work the best, but I'm gonna say that it works.
Mhm.
And then you don't need to. That's just the distance, which is the kind of use the route of the airplane. In general, whatever is going to be resource consuming for us is resource consuming for. Honestly, if somebody gives me the longitude and latitude, I panic. Okay, I have to remember that is it the west side or east side or it's on north side in general. Okay, but just if I tell you, let me just ask you one thing. The distance between here and Ottawa is 400 kilometers. And from here to Montreal, hopefully 600. Do you expect by just this information, it's going to be 1.5 more time consuming to receive any parcel from there?
Yes.
But if I say that the longitude is 54.26 and something,
I mean,
you should just
which
go and get
translates
some.
to the location name, right? Like if we have the location name, we
Mm.
have the latitude and longitude.
Okay.
So if I say that like the parcel from Toronto to Ottawa
Mhm.
or from Toronto to Vancouver, like which one is time consuming? So
Mhm.
which is more generalized and we'll have
Okay.
more information. So
Okay.
that's what.
Mhm.
Okay.
Well, that's a valid thing, but in general,
Okay.
even if it is, well, I think that was a good kind of thing to say that we come up with the idea that, okay, we can understand something out of it. In general, if we have option to choose simple ones, we go towards that, right? So anyway, we can, after we said goodbye, you have to stay here and I'm gonna convince you. So after this, we can just have these three things for the features. It should be informative, independent, and simple in general. By saying that, I guess we have a good start. So if I want to tell you a few more things is, all of you have access to the content of semester. Here you see that there is sessions and there is resources. And if you go here, what I want you to do, we already said that. Guys, did you have any time to finish chapter 1? Or don't feel bad if you don't have any time.
No. Yeah, I have that.
You have done it, so you don't look like that. Okay, don't worry. So,
How can I have access to these files?
There.
he tries to ask the questions for those who see the video. If you remember that amazing team,
I'm
so
there.
you're there. So we had these files. George Brown, ML0.
Oh, okay.
Yes, these are the
Got
files.
it.
Okay, cool. So let me just forward it to our group again. Amazing. So now you have it in down. No, honestly, because it's so up there. So now you have it. If you open this, one of them is just showing you this folder, sessions, and the other gives you not only this folder, but also the resources. Right? Just we have the resource. And the resources, you see there are two versions. One has highlights, and the other, so that was my, what do we call it, understanding that these should be highlighted. And I added those boxes to say, okay, these are important things. You can just read the plain version that you have. So for the thing is, for those who joined for this session, please let's spend 2 weeks to finish the first chapter. It's going to be very easy. It takes something like maximum. If you just read something like 2 pages a day, you're gonna finish it in 15 days. And then the next part is NumPy. And NumPy is amazing NumPy sort of presentation. And in NumPy, if you go there into sessions, look at this one. In basics, you need to read the book. And in basics, we have something that said week 01, a lecture. And that lecture is what we discussed in the previous session that we had with Suho and Alec. But the thing is, you just simply go to the slides, please, and see if you have any question. We can just, this is, for example, something that I talked about it. I said we have artificial intelligence in general, machine learning, deep learning, and data science needs, it's gonna touch all the parts, plus you need to have some statistics and some math, and also it goes to distributed databases and maybe simple databases, so it has some parts in other disciplines. By reading this and by reading chapter 1 for 2 weeks, we are good to go to NumPy. The last thing that I want to tell, if we cannot have any session after 2 weeks, so guys, let's just, I know that you're busy, but let's just finish it in the reading week to be ready. And in this part, in NumPy, you see 0, 1, 1, 2, 3, but we have total. Forget about the rest, just you need to work on total. Why I have provided all this? This is exactly the codes that you can find in chapter 2 of the book. I technically split it into different parts because I didn't want to give the students all the code. I wanted them to go through it, face problem, and then they have the solution. This is the whole solution. Please don't use it unless that you see that it doesn't work for some reason. So just compare what you have and what is there, and you're gonna be the master of it. For this one, based on the easy language that we have here, it's not gonna take more than, let me just see how many pages it has. We need 2 more weeks. And hopefully the next session that we have, we are going to spend something. If it is 1 session after 1 month, it's gonna be a long session. So high probability you're gonna start something sooner, like 5:30, and we are gonna end it up something like 9. With enough, yeah, it is, as you see, it has almost 60 pages, more than 60 pages. So you have enough material for 2 weeks finishing chapter 1, 2 weeks finishing. Now by totally 1 month if you cannot meet each other. After that, you're going to have regular, either bi-weekly or weekly sessions together. Thank you so much for your patience. And finish. Thank you.